The next thing we're going to do is we're going to do exactly that. We're going to develop some lateral behavior. By that we mean that our ball, which is inside of the world class's sports bag, can now have a relationship to the other balls that are also in the sports bag in a very clear way, right? So instead of just them being drawn over the top of each other, we can actually have them collide and maybe even verify those collisions with a particular color change for each object, right? So we're going to add some more functionality into the ball class. Okay, so we've been talking kind of very generically about behavior. So let's go ahead and define it at this point. Behavior occurs when interaction happens across objects or across those objects' properties that are related by fixed structures. Okay, so what does that mean? Well, whenever we want to see behavior, right, we kind of insinuated at behavior by calling the functions that the circle did bounce and drag, because what those functions were doing were relating the object, the circle, to the environment. Anytime that it reached the maximum extents of our window at the lower edge, it would bounce, right? So that's a fixed structure, a fixed relationship. Bounce if you reach the edge, right? So we've already been developing some simple behaviors, but they've always been between the object and its environment. So now let's go ahead and look at how we might take an object and relate it to other objects in the environment as well as to the environment. So we'll create kind of a lateral relationship between objects. So how do we do that? Or why did we take the last step? Well, this is our kind of anatomy for what happens when we're trying to nest objects inside of the world or nest classes inside of other classes. So whenever we have, let's say, we want one ball to look to the other ball to understand if it should collide, well, the object needs to look through the world class to the sports bag as a way to go down and find the properties of the other objects to influence what it's supposed to be doing in its secondary methods, and consequently how that relates to the update method, right? So by going back to the world, right, the balls can really only interact with each other when they're in a kind of context that is larger than them. So that's the world, right? So in order for them to collide, we're going to look back to the world as a way to find other objects that are close and then subsequently change what they're going to do. Okay, so let's go ahead and implement that. This is where it starts to get really dynamic and fun. All right, so this was exercise 5, so we'll save and save as. This is now exercise 6, ball and world with behavior. All right, so what are we going to do here? Well, this is the topic isn't nesting classes, but lateral behavior. Okay, so what we're going to do is inside of the ball class, right, we need to add some new functionality, right? So let's go to the ball class, and we're going to make a new method called collide. So I'm going to go down to the bottom right before drag, and this is where I'm going to add my new method. So this is called collide. Open parentheses, close parentheses, open curly brackets, close curly brackets. All right, so the collide here, this is going to be a way for us to relate one ball object to another. Okay, so first thing we're going to do is we're going to loop through, so we'll pseudocode this first, loop through all of the ball objects, all right? Then we're going to go to the sports bag and get the other ball, right? Not the one that's looking, but all the other ones that are around it, right? One by one. We're going to calculate the distance right? That's between the current ball and the other ball. And if that distance is below a threshold, then we're going to reverse and dampen the speed. Okay, so that's the basics, right? So let's go ahead and implement this, right? Loop through all the other ball objects. Well, we know how to do that. We set up our for loop. For, open parentheses, int I equals 0, I less than. Now here, we want to not just use the value that is in the main tab here, numBalls. We don't want to use that variable. We want to have this be dynamic. And the way we can do this is because, or the reason we can do this is because the balls are all stored in the sports bag, which is in the world, right? So first we look into the world, my world, we look into the sports bag, and then we get the ball, which is corresponding with index I, right? So we're moving from the world into the sports bag to the method get of the array list using the dot syntax, right? myWorld.sportsBag.get. All right. So that's the how many times we want to do it. Sorry, not get, size. That's how big the array list is. All right. So less than the size of the array list, I plus 1. Sorry, I plus plus, close parentheses, open curly brackets, and then down here I'm going to add my close curly brackets. Okay, so again, we're looking into the world. If I'm this ball, I'm looking into the context of the world. All of these things are being stored in the sports bag. Then I'm going to step through each one of them inside the sports bag. All right, so we're going to now get the other ball, right? And this is going to be, first we have to say ball, we'll call this other, this is the other ball, equals, cast it as a ball, and we're going to get the myWorld.sportsBag.get I. All right, again, we go to the world, into the sports bag, and grab the current ball object. Right? Cast it to make sure it's the right type, and it goes into this variable name. All right. The next thing we're going to do is calculate the distance. Right. So this is a simple equation that you can grab from the web if you don't already know it. So we're going to say that there's going to be a float called distance, and the equation is that we're going to take the square root, open parentheses, that's SQRT, open parentheses, the difference between x squared plus the difference between y squared, all within the square root. So that's going to be, to take the square, you have to do pow. So pow, open parentheses, the difference between the x positions. So the way to access the other ball's x positions is call the variable for the ball, other, dot xpos, because every ball object has this property. And then we'll subtract the current xpos. That's the one that is looking to collide. That, and then comma 2, close parentheses, plus pow, same for y, other dot ypos minus ypos, comma 2, close parentheses for square root, and semicolon. That's the distance. All right, and then we set up our conditional statement. If the distance is less than, and here we need some threshold value. So how can we define a threshold value? Well, if we take the other radius and add it to the current radius, we know that they will be touching at their edge. So if it's smaller than that, that means that they've collided. All right. We also need to say that that needs to be smaller than that condition, but also, so and distance has to be greater than 0. Now the reason that we're going to add that into the conditional statement, if I close parentheses, close curly, open curly brackets, and close curly brackets, the reason we're going to add this is because what if we are looking into the sports bag and we find ourselves? We want to ensure that by doing distance greater than 0 that we're not behaving because we found ourselves when we're looking to collide. All right, so we've got that set up, distance greater than 0. Let's reverse and dampen the speed. Okay, so here we're going to say that x speed equals or times equals negative 0.98. So we'll reduce the speed by 2% and reverse it, right? So reduce and reverse. So reducing the speed is kind of a dampening effect. So they lose momentum when they run into each other. Do the same for y speed, negative 0.98. Okay. So now we've got the basic collide method done, so we need to make sure we add the collide method to our update. So we do collide, open close parentheses, there's our semicolon. All right, we're close. Something's happening that's different than before. If we hit run, we'll see that they start to bounce, but we have a kind of, they're kind of sticking. So let's double check our collide method. Make sure that we haven't mistyped anything. Distance less than other radius plus radius. Okay.